Good day everyone. Welcome to another video on this lecture series related to machine learning. In this particular video, we will be discussing about the gradient descent. So basically in our last lecture, we were discussing about one machine learning algorithm that is linear regression. We said that we have a training set, let's suppose X, and this X is our matrix. It contains input, and the input is in such a way that every row, so here we have a row, every row represents one example. Okay, so in every row the first element will be 1, then we have x 1 1, x 1 2, so these are its features, x1 n, and we have total m examples. So it is the input containing input of m different data points, and the size of this matrix is m cross n plus 1. So this was our input, and the output for this is our y. This is the actual output in the data set, and y is y1 y2 dash 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 ym, since we have total m data points, so the size is m cross 1. And to train a model on this particular data set, we said that we assume a function, a linear function, h of theta x. Okay, it is a linear function, and we said that this function will capture the relationship between the input and output. It will say that this hypothesis function is equal to theta 0 plus theta 1 x1 plus theta 2 x2 plus dash 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 plus theta n xn. So if there are how many features? N features. Okay. Now our aim is to find the optimal value of these parameters such that this hypothesis function is similar to the actual output. Okay, and these parameters, we wrote these parameters in a matrix format like this: theta is equal to theta 0, theta 1, theta n. So the size of this matrix is n plus 1 cross 1. Okay, and our aim is to find the value of these parameters to find one particular hypothesis function that matches the actual output. Then we will use this particular hypothesis function to predict on an unknown data that is not known to us. Okay, and for that reason we said that we will do one thing: we will first find mean square error, and the mean square error is h of theta x minus y whole square. So this is for one particular example, but for all the examples, all the m examples in the data set, we will have the sum of this xi yi, and this will be equal to I running from 1 to m, and at the first we write 1 by m because it is the mean. Okay, 1 divided by m. So our aim is to reduce this. In matrix format we write it this mean square error, it is also called a cost on theta, and it is a function of theta because we are changing the theta. Okay, so the cost, this particular cost or mean square error in matrix format is also written like this: 1 by m x dot theta minus y whole square. Or we can also write it like this: 1 by m x theta minus y transpose int x theta minus y. because square in matrix format is written like this. So this part we have already discussed. Now our aim is basically is to find theta, okay, find theta such that j of theta is minimum, or I can write it j of theta is equal to 1 by m summation I running from 1 to m h of theta xi minus yi whole square. So we have to minimize this, and the theta that minimizes this is our optimal theta, and then we will have our optimal hypothesis function. And you can see that this particular function, it is a quadratic function. So basically we have to minimize theta, j theta, and as I am saying that j theta is a quadratic function. And one important algorithm, or we can say one most frequently used algorithm to minimize this particular function is gradient descent. Okay, so we will discuss this in detail. So gradient descent is a optimization algorithm that is used to find the optimal value of theta that minimizes this particular value, or that minimizes this cost, or we can also say that minimizes the mean square error. Now, as I said that this is a quadratic function, so the graph of a quadratic function is like this. It is like this. Okay, so for this particular function, and for simplicity here I am showing it as a one dimensional, sorry, on two dimensional. So here we have a theta from this side and we have j of theta. Okay, so this is our theta from this particular side. Fine. So also here I am only considering one value of theta because it is a single dimension. So I am assuming that theta is one dimensional, but theta is a multi-dimensional quantity. For simplicity, for understanding, I am showing it only a one dimensional so that we can understand gradient descent. Okay. So now we have to find the value of this theta where this particular quantity is minimum. As you can see that this particular quantity is minimum here at this particular point. Okay, so the theta at this particular point will be our optimal theta, and we already know that since this is a quadratic function, so its graph will be like this. Okay, now what gradient descent does, it first what it does, it gives some initial values to theta. Okay, some initial values are given to the theta. Those are any values of your choice, or we can say random choice to theta. Let's suppose if my theta has two variables, theta 0 and theta 1, so it is also given one value, it is also given one value. But in the example that we are saying theta is, how many thetas are there? N thetas, n plus 1, sorry, theta 0, theta 1. So we will initialize all these thetas with some random values or with some initial values. Okay, so that means on this particular graph we are initially choosing some theta. So this is our initial theta. Okay, and this initial theta may be on this side, or anywhere here. It can be anywhere. Okay, so after choosing the theta, then what we have to do, we have to move theta in the direction of decreasing j theta. So what I am saying that initially we have chosen theta here, or maybe we may have chosen here theta. Okay, now let's suppose if I have chosen from this side, then what I have to do, the next theta I have to change the theta. So that means I have to move in this direction, why in this direction? Because my j theta will be decreasing in this direction. If I go in this direction, but in this direction j theta is increasing, so I have to move in the left direction. But if my initial theta was here, I have to move in the right direction. So how will I found whether my j theta is decreasing in the left side or in the right side? So how will I decide whether my j theta is decreasing if I move to the left side or if I move to the right side? So that means we have to choose the direction of changing theta. And how will we choose the direction? We will choose that particular direction in which direction j theta is decreasing. Okay, for example, here if my theta was here, I have to move in the left direction. Why in the left direction? Because my j theta is decreasing in the left direction. However, if my theta was here, then I have to move into the right direction. Why in the right direction? Because my j theta is decreasing if I move into the right direction. Okay. So that means if my theta was here, the new theta will be theta minus, because I have to move in the left direction. My theta was here. I have to move in this direction. Theta minus something. What something? We will see it in couple of minutes. And if I was on the right side, then my theta should be equal to theta plus something, new theta. Fine. So the update should be either theta is equal to theta minus some value or theta plus some value, and it is decided where the location of the theta is. Now we have to choose how we will find whether the j theta is decreasing in the right side or in the left side. So this question we have to answer. How we can find out? We can find out this. So if I have a particular theta, now at that particular theta I have to find whether j theta is decreasing in right side or left side. So we have to decide this, whether it is decreasing in right or left side. So if it is decreasing in right side, by moving in right side, then I have to do theta is equal to theta plus some quantity, some positive quantity. Okay. And or I can say theta, if it is decreasing in the left side, then I have to do theta is equal to theta minus some positive quantity. Or I can combine these two together. Theta is equal to theta minus some quantity. And this quantity will be positive if j theta is decreasing on left side, by moving to left side, and it will be negative if we have to move on the right side, because negative will be positive and it will be plus here. Okay, fine. So this quantity decides whether it is positive or negative. Now we are here. So how we can find out whether j theta is decreasing in the right side or left side? What we can do, at this particular theta we will find slope of this graph. And what is this graph? This is basically j theta. This is the graph of j theta, the cost. We will find the slope of this particular graph at this particular point at theta. Okay, by finding the slope we can say whether j theta is decreasing on the right side or on the left side. So if the slope is negative, so there are only two possibilities: slope is negative or slope is positive. These are the only two choices. This slope will be either negative or positive. Now, if the slope is negative, that means j theta is decreasing by moving to the right side. You can see here. So, if our j theta was here, now I will draw a slope here. Okay, slope to j theta. And this slope to j theta, you can find out that this slope is negative slope. So it is basic mathematics. The slope of this line will be negative. So when the slope is negative, that means I have to move into the right direction. And if I have chosen this theta as here, now draw a slope here, this will come a positive. This is positive slope. So that means I have to move into the right direction. So what I was saying that we have to update theta. Our aim is to update theta. And how we are updating theta? As I said, we will do theta is equal to theta minus some quantity. Theta minus some quantity. And this quantity, as I said, that this can be positive or negative. And this quantity will be positive if we have to move into the left direction, and negative if I have to move into the right direction. Now, whether I have to move on to the left and right direction, I have to decide it from j theta. So I have to move in that particular direction in which j theta is decreasing, because we have to decrease the j theta. Okay. Now, what I am saying, I will find the slope of j theta. Slope of j theta at theta. Okay. Slope of j theta at theta. Now, slope of j theta, we can also say that it is the differentiation of theta with respect to theta. So this is also, this will give us the slope of j theta. So we will find this particular quantity. So if this quantity, so there are two possibilities. This quantity can be positive, can be negative. So this quantity will be positive if the slope is positive. This quantity will be negative if the slope is negative. So if it is positive, then we have to move in the left direction. And if it is negative, then we have to move into the right direction. Now, as I said, this theta will be equal to theta minus quantity. If at this particular quantity, I said that this quantity should be positive if I have to move into the left direction, this quantity should be negative if I move into the right direction. If I write theta is equal to theta minus j theta by differentiation of j theta by theta. Now you can see this quantity should be positive if we have to move into the left direction. Okay, now from here you can see when is this quantity positive? When we have to move into the left direction. So that this point is clear. Now it is saying that this quantity should be negative if I have to move into the right direction. And we already know if I have to move into the right direction, this quantity will be negative. So this particular quantity is positive if we have to move into the left direction, and this quantity is negative if we have to move into the right direction. So this will be our update rules. Update rules for theta. Okay, or we usually write theta is equal to theta minus alpha. So alpha is also called a learning rate. So we will discuss this learning rate as well. This is learning rate. So this will say how far, how big jumps we are making, this alpha. So as I said that you can see here, I am saying that initially we have chosen theta. Now let's suppose I have to move into the left direction. By how much quantity I will change this particular quantity? Should I move, let's suppose, should I, the new theta, should I add a large quantity or a small quantity? Sorry, should I subtract a large quantity or a small quantity? It is determined by this alpha. So if the value of this alpha is large, that means we are making big jumps. So if alpha is large. Okay, so this was our graph. This was our, let's suppose, initial theta. Now if I am making big jumps, so the next theta, it is possible that the next theta is here. So new big jumps. Another time here, here. It is moving like this. So there is a possibility that it will not reach to the minimum. Okay, but if this theta is small, sorry, alpha is small, that means we are making small jumps. What does that mean? We are making small jumps. So our graph was like this, convex. So theta was like this, let's say. Now new theta will be here, then here, then here. Abruptly after some time we will reach to the minimum point. But the disadvantage is, if alpha is very small, we are making very small jumps, so that will have a disadvantage that it will be slow if alpha is very small. Okay, so you have to do different experiments to find out what alpha we use. I will also show you how you can choose the alpha, but initially you should use alpha as 0.1, or sometimes you can also use 0.01 or 0.0. Okay, so this is called a learning rate, or we can say how fast we are changing theta, alpha. So what are our update rules now? You can see that our update rule is theta is equal to theta minus alpha times okay. So this theta is the entire theta. It includes theta 0, theta 1, theta 2. Let's update each theta separately. So let's take one of the theta. Okay, so let me take any theta. Let's suppose theta j. So if I have to update theta j, so theta j will be equal to the old theta j minus alpha times differentiation of j theta with respect to theta j. So this will be our update rule, and we have to do it for every theta. So for every, yes, theta. So for j running from 0 to n, because how many thetas are 0? The thetas are there, theta 0, theta 1, theta 2 up to theta n. So theta j will be equal to theta j minus alpha times differentiation of j theta with respect to theta j. So let's now find this differentiation. So differentiation of j theta with respect to theta j will be equal to, so what is our j theta? So it will be differentiation of, so j theta is our 1 by m summation I running from 1 to m h of theta x minus y whole square, xi yi. Okay, or I can write it like this. Take 1 by m outside, it will be 1 by m differentiation of summation I running from 1 to m h of theta xi minus yi whole square. So it will be equal to, so we already know that differentiation of x square with respect to x is equal to twice x into differentiation of x. Here x is this one, so we will write it like 1 by m twice into 2. 2 is, it will come outside, summation I running from 1 to m h of theta xi minus yi into then differentiation of x. So this is our x, this part. So we have to do differentiation of h of theta xi minus yi with respect to theta j. Okay, now this particular part, let me write on a different page here so that we will put it here. So it will be, so differentiation of theta j, this h of theta xi. So this is equal to theta 0 plus theta 1 xi1 plus theta 2 xi2 plus dash 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 plus theta n xi n. So at some point it will be theta j into xi j minus yi. So we have to do differentiation of this with respect to theta j. So differentiation of this with respect to theta j will be 0 because it is not related to each other. This 0, this one. So here this is an independent quantity. So it will be differentiation of theta j x ji. So it is the jth feature of ith example. It will be equal to differentiation of this with respect to this is 1. So it will be xji. So the output will be, let's leave this, output will be xij. So this will be the output of this particular quantity. So I will write it here. So what was, then we have to do differentiation of this particular quantity, and that is coming out xij. Okay, 2 by m summation I running from 1 to m h theta xi minus yi into this. Okay, so let me write it in clear terms now. So I have to do one thing. Yes, so it is, this implies j of theta with respect to theta j is equal to 2 by m summation I running from 1 to m h of theta xi minus yi into xij. So this is our, so what was our updation rule? So you can see our updation rule was for I running from, sorry, j running from 0 to n, because we have to do it for every theta. Theta j will be equal to theta j minus alpha times j of theta with respect to theta j. So this was our we can say our update rule, or we can also write it, this implies theta j will be equal to theta j minus alpha times, so what is now theta j with respect to j of theta with respect to theta j, 2 by m this particular quantity. So it will be into 2 by m summation I running from 1 to m h of theta xi minus yi into xij. Okay, or I can write it like this, theta j minus alpha times. So there is one thing in this particular, so this is complete constant, this particular constant. As I said that this particular constant determines the jump. What is the size of jump, whether we are making a small jump or large jump. So you can easily neglect this particular quantity 2 by m, because it only determines the size of our jump. If we neglect this, that means we can incorporate these two itself into the alpha. So we can easily neglect 2 by m. So let's leave 2 by m here. We will write it I running from 1 to m h of theta xi minus yi into xi j. Okay, so let me write here again the same equation I am writing for clarification again. So for j running from 0 to n, our theta j will be equal to theta j minus alpha summation I running from 1 to m h of theta xi minus yi into xi j. Okay, now I have to update each theta. So that means I am updating this particular theta. So this particular theta means I have moved 1 point down. Now again, now still I have not reached to the minimum, because I have to reach to the minimum. I will again repeat same thing I will repeat again and again till I reach to the minimum. So what is this minimum? Minimum means where this loss is minimum, j theta is minimum. So we have to do these updates repeatedly. So that means we have to do this thing till j theta is minimum. But how do we know that we have reached to the minimum point? How will we stop, or we can say what is the stopping criteria in this particular scenario? The stopping criteria is that if in 2 iterations or if in multiple iterations there is no further significant change in j theta. So if our j theta is not changing now, when we are again updating and there is no change in the j theta, we will stop. Stop means that we have reached to the minimum and now we are only moving here and there at the minimum itself. Okay, so at this particular point we will stop, and whatever our thetas will be, so those thetas will be our optimal thetas. Okay, so those will be our optimal thetas. Fine. So this is how gradient descent works. So let me summarize it. Gradient descent. So gradient descent is trying to find an optimal theta that minimizes this j theta, and it is doing this by moving in the direction of decreasing j theta. So that is why it is called a descent. Descent means decreasing cost or j theta, and gradient here means that we are finding the slope or decreasing side of j theta. Okay, that is why gradient descent. So we are trying to find the minimum value of j theta, and how we are doing that? We are doing that by updating our theta by this particular equation, and we have already find out why this particular equation. Okay, so with this we will stop the discussion about the gradient descent, and in the next part of this video we will again continue the gradient descent algorithm. Basically in the next video we will see how we can write gradient descent in matrix format. Okay, because in Python programming everything will be in matrix format, so we have to understand how we can do it in matrix format as well. Okay, so let me stop this particular video and we will continue the discussion in the next video as well.